Hello teacher, I am Musa. In today's segment, we are focusing on thoroughly testing the initial implementation of the list classes with all its functions and tail reference. We will write a test program with all the all the methods and examine in detail the execution time complexity, best and worst case screeners of each method. We will also compare the list, list, and the improved list classes and evaluate their advantages, disadvantages, and application areas. This will allow you to better understand the difference between array-based and linked list-based data structure and see how creating operation can be improved with optimized structure. Now let's start our testing and analyze process. The node class defines a generic node structure used in linked list data structure. Each node contains a piece of that data and a reference to the next node. The constructor method creates the node and fills the data field until it's setting next to null. This structure provides a basic functions for chaining nodes in linked lists. In this work, we designed and analyzed a class called list based on the link list structure. This class includes the basic operation that can be performed in a list data structure and provides data management with a node based structure. The code is both sys aware the optimized performance and flexible to work with different data types. This design provides a powerful example for understanding practical applications of algorithms and data structure. For the assignment, I will explain and evaluate how each method of the class works. We define a class called linked list. Height, height is a reference pointing to first node of the list. It is derived from the node T class and contains the data of each node and it is linked to the next node. A size of the total number of elements the list. This value is updated each time it is added or removed. This is the default constructor of class. It is entirely set to null, meaning the list is entirely empty. Size is set to 0 because the list entirely has no elements. This method is used to add an element to the end of the list. A new node is created and the given data is inserted into it. The list is empty and the new node is assigned as the heat node. If the list is not empty, the new node is assigned to the end of the list. Finally, new node is assigned to the next reference of the last current node, and the size of the list increased by 1. This method is used to add elements to specific index. It checks if the index is valid. If the index is invalid, an exception is thrown. A new node is created and the given data is assigned to. If the index is 0, the new node is added to the head, and the next reference of the new node points the current head node. Then then the new node is assigned as the head node. If the index not 0, the nodes are traversed up to the specified index. The new code receives the next reference of the current index and is itself assigned as the next reference of the previous node. This method removes an element a specific index from the list and returns the removed element. It checks for invalid index status and covers an error. If the element to remove is in the first node, the height node is updated and the data of the height node is stored. Process the corresponding node store the data of the removed node and update the next reference of the node, thus linking the list. The size of the list disrupted by one and the data of the removed node is returned. Returns the data of the node at a specific index. The index checked if invalid an error is thrown. Cycle target the nodes until the desired index. The data of corresponding nodes returned checks if there is a specific data in the list. Starting from the head node, all nodes are checked, returns true if data is found, false otherwise, returns the total number of elements of the list. It checks if the list is empty, returns true if the list empty, false otherwise. As a result, we examined the linked list a class in detail and learned how it performs basic list operation. By using the linked list structure, we provided flexible and dynamic data management. Understanding the function of each method was an important step in evaluation the effectiveness of algorithms and seeing the practical application of a data structure. This study was valuable but for putting theoretical knowledge into practice and for understanding the importance of data structure in software development process. In this study, we examined refined linked list, a class which contains a reference to the last node. This class provides efficient data management by enhancing the basic functionality of the linked structure. In particular, detail reference optimize performance by speeding up the process of adding elements to the list and deleting the last element. The class provides a flexible and dynamic structure with functions such as adding, removing, searching, and controlling the list. This design plays an important role in algorithm and data structure application by increasing the efficiency. Linked list as a part of the assignment. I will analyze this class in detail and examine its particular uses. Class initialization and variable definition. The reference linked list a class is designed to make the list data structure more efficient. A head points to the first node of the list. The head node is the starting point of the list and linking list operation usually start tree and tail points to the last node of the list. This reference point directly to the last node, optimizing operations such as adding elements to the list. Size holds the total number of elements in the list. This variable is updated every time an element is added or removed so that the list size is always correctly tracked. Default constructor. When a new refinite linked list object is created, a hand and a tail and are utilized to null. The list is initially empty. Is set to 0 because there are no elements at the beginning. Adding of element to end. At add method adds a new element to the list. A new code is created and the data values are placed in it. If height is null, the new node is assigned both head and tail. This is the first element in the list. If the list is not empty, and the next reference of the existing tail node points to the new node. Tail is update as a new node. This approach makes the insertion process fast as it provides the direct access to the last node. Size increment by one so that the number of elements update correctly at element specific index. The insert method inserts a new element at a specific index position. It checks if the index entered is valid. If the index is negative or larger than the size of the list, an error is thrown. A new node is created and the data values inserted into it. Insertion and status. If the index is 0, the next reference of the new node points to the existing head node. The new node is assigned as head. If the list empty, the new node becomes both head and tail. And append status. Uh, if the index is equal to the end of the list, the same operation is performed as with the add method. A tail point next points to the new node. A tail is assigned as the new node at the counter state process until the specific index. A new node is added between related nodes. The reference of the new node is set to the next reference of the exist node. The next reference of the current node points to the new node. The number of elements of the list is increased by one. Delete element. The remove method deletes an element in specific index and returns to the data of the delete element. It checks if the index is valued. If the index is invalid, an error is thrown. And delete from initialization if the elements to the removed is in the head node. The head node is updated. The data of the removed elements is stored. If the list is empty, the tail is also set to null. A delete middle or last element scroll up to the corresponding index and update the nodes. If the removed node is the last node, tail is update to the provided node. The number of elements of the list is discriminated by one. The data of the removed elements is returned. Other methods get returns the data of the elements at the given index contains checks if there is any specific data in the list. Size returns the total number of elements the list is empty. It checks if the list empty. Refinite linked list optimize operation with the last not using the tail reference. This makes operations such as adding elements to the list and checking the last much more efficient than the standard linked list implementation. This class provides an excellent basis for a dynamic and flexible data structure. This program is designed to the best basic functionality of the bus linked list and referent linked list classes. The operation of both linked list constructors such as inserting, deletion, searching and checking elements are comprehensibility evaluation using a generic test method. The same operation are performed on different lists implementations and the results are compared. In this way, the performance advantages and efficiency of the referent linked list, a class with a tail reference are analyzed. This test provides an important set to understand the structural difference and use cases of linked lists. A class called linked list test is being created. The class is designed to test the functionality of both the linked list and referent linked list classes. It is the entry point of the Java program. The program is started by exciting this method. A basic linked list test is printed to the console. The test linked list method is called on instance of the linked list class is pasted into the method advanced linked list test is printed to the console. The test linked method is called an instance of referent linked list class is passed into the method. This method is a generic method designed to test both the linked list and referent linked list classes. The object list parameter tests the list to be tested. It is checked if the type of the list object is linked list. If list is an instance of linked list, it is converted to linked list string. The elements apple, banana, and cherry are added to the list respectively after the elements are added to the list. The list size is checked and printed to the console. Expected size 3. The element at the index 1 of the list is taken and printed to the console. Accepted result is banana in index 1. The element that data is added. Check the list size and verify that the added elements placed the index. Check if the element cherry is in the list. Expected result is true. Check if the element fig is the list. Expected result false. The elements in index 2 banana is the delete from the list. The delete element is printed to the console and the list size is checked. Check if the list is empty. The expected result is false. If the list is a referent linked list instance, it is converted to referent linked list string type. The elements apple, banana, and cherry are added to list. The size of the list is checked and printed to the console. The first element of the list is taken and printed to the console. This program tests basic functionality of both a linked list and referent list classes and prints the result to the console. The generic test method makes it easy easy to list different types of lists and analyze the results. In this study, we examined the tested different implementations of linked list data structure in detail. By analyzing the basic function of the linked list and reference linked list classes line by line, we learned how operations such as adding, removing, searching, and size control work. The performance advantage of adding the tail reference in the reference linked list class were clearly demonstrated. We also wrote a test program to evaluation the function of these classes and analyze their strengths and weaknesses. This process provided a valuable learning opportunity to understand real life applications of linked list data structure and create optimized solution. The knowledge again during the assignment provided a solid foundation for algorithm design and data structure selection. Thank you for watching the video, teacher. See you later.